This is my review video for the Algebra 1 Chapter 8 test or practice test. As you can see from the very top of the sheet, if you open this up from Canvas, it'll look like it's opened up, but click on Open With at the top and then select Google Docs, and that way all of the problems will open the way they should. So as you can see from the first two problems that are on the document camera, I have gone ahead and already graphed the parent function, which is f of x equals x squared. And on these two particular problems, you have to graph another function and then describe what the transformation is from the parent function to the new function. And I'm going to suggest that you do use Desmos to go ahead and do that. So in the background, I have Desmos running, so I'm going to go ahead and try to switch and see if it will let me do that. This number one, it says to graph g of x equals 1/2 x squared. So I'm going to go ahead and switch to Desmos. And from Desmos, I have all of the problems in here that I know I'm going to use. So right now you can see the parent function right there on the graph. And if I activate the second one there, that's g of x is equal to 1/2 x squared. You can see it in blue. Now remember, if you do want to put the points on another piece of paper, what you need to do is click Edit List, and then you can click on the table, and that's one way that you can see what some of the points are. It might be clearer than looking at the actual graph. If another one is missing, let's say I want to know what is it doing at 3 and x is equal to 4. You can put those in. There's 3 and 4. So I'm going to pause my video and transfer those points to my graph. I've now gone ahead and transferred g of x equals 1/2 x squared onto the paper. I'll zoom it in. And while we're doing this, of course, pause the graph, or the video, if you do need to write anything down or if you want to just look at it. So that's the graph. And on the actual test, you're not going to be graphing, but I will be asking you to describe the transformation. So this one, the way I would describe this is a vertical shrink, and that's what's causing it to look like it's flattening, which is getting wider, and then by a factor of 1/2. So that's what that number was out front. That number represents A, and A can cause a vertical shrink or a vertical stretch, and it can also cause the parabola to reflect across the x-axis. I'm going to go ahead and move over to the next one, and you can see that my next graph has a different form here. So this form is actually what we call Vertex Form. And it's called Vertex Form because by looking at it, you can tell what the vertex is. So you would normally have f of x is equal to x minus h squared minus or plus k. H controls left and right movement. K is up and down. On this particular one, notice there's no minus there, so think of that as x minus -3. So h is -3 and k is -5. That does tell us where the vertex is. It's going to be at -3, -5. I'm going to go ahead and switch to Desmos again. And here we are with Desmos. And I'm going to, let's see, I'm just going to erase this one. I've already finished that one, so I'll turn that one off and erase it, and I'll turn on the one we were just looking at. And notice it has been moved to the left and down. If you want to see those points, I already showed you how to do that. You can also just click somewhere near the vertex and they will pop up. And here's the other one. And you can see -3, 5. I'm going to pause the video so I can transfer the parabola over. All right, I've now gone ahead and transferred it over. Notice it is right where I thought it was going to be. The vertex is at -3, -5. But to describe the transformation, I'll move this down. And this one would be a horizontal translation three units left and a vertical translation 5 units down. Now the next one is really just asking you to go ahead and graph that. So I have that also over on this screen, so I'm going to close the one we just did and turn on this new one. Now I don't need to compare it to the parent function, so I'm going to hide the parent function in case I need it later. So there is my graph, and I'm going to pause to transfer that over. All right, I've gone ahead and transferred it over, and on this particular one I will probably give you 4 or 5 pictures of graphs, and you will just match the one that goes with the one that you did on Desmos. So moving to number 4, as you can see from the directions, it says we're going to graph another function, and this time we're going to determine whether it has a maximum or minimum value and what that value is. So first off, let's go ahead and take a look at this. So it is right there, and I can tell you right now that because it is opening up, that means that this point at the bottom, which is the vertex, is a minimum value. It's the bottom of a parabola that is opening up. Now to see exactly what it is, I'm going to zoom way in, and to make it easier to see, I'm going to turn off the minor grid lines. Now, it's still hard to see exactly what it is, but what's nice about Desmos is that if you just click somewhere near the bottom, it'll tell you what the vertex is. So, once again, this is the minimum because it's the bottom. If it was opening down, it would be a maximum. But this is the bottom of a parabola, so it's the minimum value, and that value is given by this number, the -0.083. So I'm going to switch back over to my paper right here, and you can see that this is a minimum, and it was -0.083. So maximum, I'm just going to put a little note, that would mean it opens down. Minimum would be opens up. And just so you're aware, I'll put a little star right here, will be a whole number on the test. Okay, so I won't have something like that where you have a decimal. Okay, and I won't have a fraction either. All right, we're halfway done. I want to see if I can fit this into a 15-minute video. It's possible. So I'm going to move that off to the side. Now on this one, we don't have to do the graphing because the graphing has already been done for us. I'm going to pause the video for a moment so I can mark up this graph, and I'm trying to keep this under 15 minutes. Okay, so I put in some markings here, and I think I'm going to try wrong way. Go back out the other way. Okay, so I put a red dashed line down the middle. That's called the axis of symmetry. And I also wrote what a point is right there, the vertex, -2, -4. And because the axis of symmetry has to go through that point, it's going to be the x value of the vertex. So it's x equals -2. The other two things that this one wanted were the X-Intercepts and the Y-Intercept. So in green, I put the 2 points where it's touching the x-axis. It's -4 and 0. And you can tell I also put a purple 0 next to the origin because that's also where it touches the y-axis. So you can see all my work right there. I'm going to just slide this over a little bit. And notice on this next one, we have to graph something. And I'm going to write some things on the form, but I'm going to pause first. Okay, so this one is written in intercept form, which means by looking at the function, we can tell what the x-intercepts are. And they're represented by the letters P and Q. Now they are the numbers after the minus symbols. So I wrote here that P is equal to 1, that's the number after the minus, but Q is -3. Remember, there's no minus there, so think of that as minus -3. So without even graphing, I can tell that the x-intercepts are -3 and 1, and I also know that the axis of symmetry is going to be right in the middle between those. So I know that it's going to be x equals -1, as you can see from the bottom there. Okay? So the only thing I really need to do is to figure out where that vertex is. So I'm going to go ahead and graph that, which I already have right here. Now, I can't see it, so I'm going to hit the house and then click on the bottom there, and it's -1, -4. And you can see some other points along the way here. So I'm going to pause and put that in. All right, I'm going to wrap up my video right here. So number 6, I've gone ahead and drawn in the graph. And so the only thing I added in down there was the coordinates of the vertex, which was -1, -4. So I'm going to go ahead and zoom in now to the bottom ones. And we'll look at this one first. Now on these, we look to see whether the numbers, and we're just looking at the y values. Are the y values being multiplied by the same number from value to value? If they were, it would be exponential. If they weren't, you check the differences. So in this case, on number 7, as you can see in red there, each value is adding 4. So the difference between them is +4. We say the first differences are the same or constant. That means they will graph to make a line. So it's a linear function. Compare that to this next one here. I'm going to move out so you can see them both at the same time. So in this one in red, I also checked the first differences, and they went -3, -1, +1, and +3. So then I checked the second differences, and I noticed that -3 plus 2 is -1. If you add 2 again, you'll get 1, and you add 2 again, you get 3. So in that one, the second differences are constant, and when that happens, the function is called quadratic.